Hello, ladies and gentlemen. Welcome back to the unit circle. And if you thought that you were going to get away from the unit circle without having to work in radians, boy, were you dramatically and wonderfully wrong, because we need to understand how this works with radians as well as degrees. So, I have labeled my circle starting with 0 radians. Here's pi radians, equivalent to 180 degrees. This is halfway to pi, so it would be pi over 2. So 1 pi over 2, 2 pi over 2. This would be 3 pi over 2. And 2 pi back here at 0, that would be equivalent to 4 pi over 2. Okay, so now let's divide up this pi. Let's take and divide this pi into what we would call 45-degree slices. How many slices are there, ladies and gentlemen? Well, there are 8. I hope you can see that. But one thing you have to remember is that when we talk about this unit circle, pi is only half the pi. So if we're dividing this pi, here's pi over here, right there. Here's half of pi. What would this be? Well, this one slice represents 1/4 of the way to. So we could say that this radian measure is pi over 4. And if you don't believe me, take 45 degrees and convert it using our conversion skills from a few sections ago. And now I'm going to count. And I know counting is difficult sometimes, but this is 1 pi over 4, 2 pi over 4, and 3 pi over 4. Cool. And again, if you don't believe me, take 135 degrees and convert it into radians. So 3 pi over 4, pi would be 4 pi over 4. This one, 4 pi over 4, 5 pi over 4, 6 pi over 4, check that that reduces, 7 pi over 4, and check that 8 pi over 4 reduces to 2 pi. So what did I say? This was 5 pi over 4. 270 degrees would be 6 pi over 4, but that reduces to 3 pi over 2. And then this one right here, the 315 degrees, that is equivalent to 7 pi over 4. Notice all of these angles I've drawn and written in this pinkish red color, they're all over 4. Guess what? Any quadrant, if we're dealing with an angle over 4, we will be referencing pi over 4. And let's just refresh here from the previous video. Ordered pair that goes with 45 degrees, also known as pi over 4, is square root of 2 over 2, comma, square root of 2 over 2. Very important. Okay, so let's go to the other angles. I'm going to divide my pi now into 30-degree slices, also known as pi over 6s. So in radians, if we look at the top part of our unit circle right here, how many slices of pi are there? Well, there are 6 slices. There is 1, 2, 3, 4, 5, 6. So this first slice, 30 degrees, is pi over 6 radians. And then if we count, the second slice is going to be 2 pi over 6. We can count by ones, right? 1 pi over 6. And then 2 pi over 6. But 2 pi over 6, that reduces, doesn't it, ladies and gentlemen? That is pi over 3 radians. And if you don't believe me, check it. Check me out. Make sure that 60 degrees is equivalent to pi over 3. And then we keep counting, and we will have 1 pi over 6, 2 pi over 6, 3 pi over 6, that's pi over 2, and then 4 pi over 6. But 4 pi over 6, well, what does that do, ladies and gentlemen? That reduces to 2 pi over 3. And then we keep counting. 2 pi over 3. So go by 6s again. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then this right here, 180 degrees, pi radians, is 6 pi over 6. So let's label this one 5 pi over 6. Now let's go back to our degree unit circle, and nothing has changed now. Our pi over 6 reference angle, that is going to have an ordered pair associated with it, that is square root of 3 over 2, comma 1/2. And our pi over 3 angle will be 1/2, comma square root of 3 over 2. And remember, pi over 2, well, that is 0, comma 1. 0 radians, that is 1, comma 0. And go ahead and pause the video, ladies and gents, and I want you to see if you can label the radians down here on the bottom for this measure, that measure, and that measure. So pause the video, give it a try. Alright, so I'm going to frame this in terms of reference angles as I go around here. I'm going to label the angles that are closest to the x-axis, this one and that one first. So this angle is pi over 6 radians beyond pi. Well, this is 6 pi over 6. 6 pi over 6 plus pi over 6, guess what? That's 7 pi over 6. And then going over into the fourth quadrant, pi over 6 radians less than 2 pi. Remember, 2 pi, that is 12 pi over 6. 12 pi over 6, take away 1 pi over 6, that is 11 pi over 6 radians. Now we go to the reference angles of pi over 3. This angle is pi over 3 beyond pi radians. So 3 pi over 3, that's pi, remember. 3 pi over 3 plus 1 pi over 3, that is 4 pi over 3. Going into the fourth quadrant, this is pi over 3 radians less than 2 pi. And 2 pi, remember, 2 pi is 6 pi over 6. Sorry, 6 pi over 3. 6 pi over 3 minus 1 pi over 3, that is 5 pi over 3 radians. So these radian measures, again, all make reference to what is in the first quadrant. All of these green ones reference back to pi over 6. And notice they're all over 6. All of the blue ones here reference back to pi over 3. And notice I have them all written in blue. All of the red ones, those reference back to the pi over 4. And they are all over 4. And if you can remember the ordered pairs up there in the first quadrant, we are golden. We got this down cold. So, ladies and gentlemen, let's say I want to know what the, oh goodness, what should we do? Let's do the cosine of 7 pi over 6. First thing we have to do is recognize what quadrant that's in, and that quadrant is in quadrant 3. And in quadrant 3, remember, tangent is the only thing positive. So we know that this measure will be negative. And where do we reference? We reference the over 6 angle. Cosine is the x-coordinate, square root 3 over 2. And there we have it. There is how we use this unit circle to think about our sines, cosines, and, for that matter, tangents, and more is yet to come in the very near future.